Good morning, good afternoon, good day, wherever you are watching my video from. I hope you're having a great day so far. So, today we will continue on discussion on how to display or represent numerical data. So, we will talk today about another type of display. But before I move forward, I would like to mention that please stick with me till the end of the video. I'll give you some important tips, and also please subscribe to my video by hitting the red subscribe button, and if you like this video, give me a thumbs up. So you may have heard about the term box plot, but what really does it mean? So box plot. Okay. So why do we make box plots? We make the box plot because we can locate the center of the data, the variability or the spread in the data from the lowest to the highest, and if there are symmetry or skewness of the data. Remember, skew means either an extended tail on the right of the data in the data set or an extended tail on the left in the data set. So we are going to talk about two kinds of box plots, skeletal box plot and modified box plot. So how do we really make a box plot? This goes to the steps. I will not read into each step because we will use our calculator TI-84 to make such a box plot. So let's see, how did they do the box plot? Okay, they did the entire thing. So let's enter this data set in our calculator TI-84. The first step in entering the data in L1, list 1, is to clear the memories of the calculator. That you do by pressing the second button on the top left, then the plus button on the bottom right, plus button on bottom right, then selecting or pressing number 4 key. Second plus 4 will get clear all list on your calculator. You hit enter and you'll see done. That means you have cleared the memories of the calculator. Okay, let's reconsider the data from example 4 on improvement scores for people in a variable priority practice group. The ordered observations up. Okay, so this is the entire data set. So we are going to enter this entire data set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 data points in L1 of the calculator. How do I get started? I press the stat button in the calculator on the second row and then press number 1, which is edit. In front of me in the calculator, I have L1, L2, L3, L4, etc. L stands for list. So we will enter the data in list 1. Why? Because this is an entire data set and we will put it in list 1. So I put my cursor, it's usually set on the first line in L1, where I will type 1, 2, 0, 0 and hit enter. Then 1, 3, 0, 0, enter. Then 2, 3, 0, 0, enter. Then 3, 2, 0, enter. Then 3, 3, 0, 0, enter. Then 3, 8, 0, 0, enter. Then 4000, enter. Then 4100, enter. Then 4300, enter. Then 4800, enter. So that's the first row of data. It's in L1. I will continue to enter the second row. So right now my cursor of the black rectangle is sitting in L1. 11 means the 11th row of list 1, which is a vertical column. And the first line is first number I will enter after 4800, 4800 is 5500, which is the first data point in the second row. Then 5700, then 5800, then 6000, then 6300, then 6800, then 6800 appears twice. Make sure of that. Okay, so we have to enter the second 6800, then 6900, then 7700. Seems like I'm missing one number, so I will make sure. So after 4800 is 5500, then 5700. Okay, what I missed is 5700 appears twice. So I re-enter it 5700, then 5800, one time only, then 6000 one time, then 6300 one time, then 6800 one time, then 6800 one time, then 6900 one time, then 7700. Now I have 20 data points in L1 and my cursor, the black rectangle, is sitting in the 21st row horizontal of the vertical column L1. So that's why the cursor is on L1 parenthesis 21, 21st row of list 1. Okay, let's see. So we are going to make a box plot like this. How do I do that? After entering the data in L1, okay, we will press the second button, which is in the top column. Second button, I selected. So second button, top left, and then Y equal to key on top of it. Okay, second Y equal to. Then I will press number 1, which is plot 1. Currently, my cursor is on off. I bring it to on and I bring the cursor to on by the left cursor key on the top left of the calculator here. Bring it to on position and hit enter. So cursor is flashing on. So plot 1 is on. Okay, that's the second line. The type is the third line. What type of chart I want to make? I can make a skeletal box plot. Okay, that is in type. I move the cursor down to type and 1, 2, 3, 4, 5. Remember the fifth is the skeleton box plot. What is a skeletal box plot? It will show you the box plot just like this. Here the horizontal line on the left, as you see in the screen, is called the left whisker, extends to the minimum on the left, and the right whisker, the right horizontal line, extends to the maximum on the right. And the boundaries of the box, the two vertical boundaries are Q1. So Q1 constitutes the left boundary and Q3 constitutes the right boundary of the box. And we look at Q1 and Q3 and draw two horizontal lines connecting Q1 and Q3, and the vertical line in the box, inside the box, is Q2 or median. You can already see in the chart you have or in the plot you have on the screen that Q1 is closer to Q3 or the right boundary of the box. Rather, Q1 or Q2 is farther away from Q1, which is on the left boundary of the box. Or in other words, Q2 is closer to Q3, but Q2 is farther away from Q1. Shows you the distance from Q2, which is the median in the center of the box. The distance from Q2 to the left lowest point on the left whisker, that distance, minimum, the Q2 minus the minimum, that distance is farther than the distance from Q2 to the maximum, which is the end of the right whisker. In other words, there is more on the left part of the data structure than on the right part from Q2. So Q2 to the minimum distance is greater than Q2 to the maximum. Seems like Q2 is also closer to the right boundary. So how will I make this plot? So I bring the cursor on type to the second type of box chart, which is actually fifth. Okay. And then hit. Okay. So 1, 2, 3, 4, 5 and hit enter. The cursor should flash on the fifth type, which is the second type of chart, which is the skeletal box plot. Skeletal box plot will show you the five numbers. What are these? Minimum, Q1, Q2 in the center of the box, Q3 right boundary of the box, and maximum on the right. How do I see this on my calculator screen? I press the zoom button, that is the third key on the top row of keys, zoom, and then 9. And I will see the same box plot that you see on the computer screen, okay, on the PowerPoint slide. Okay, so lower whisker is longer. Lower whisker is the whisker on the left, is longer than the upper whisker. Upper whisker is on the right. Median is closer to the upper edge. So median, which is Q2 in the vertical line in the center of the box, is closer to Q3, third quartile. Okay, or the right boundary. So that means the distance from Q2 to the minimum on the left end of the left whisker, that distance is larger than the distance from Q2, the median, the vertical line in the center of the box, to the maximum extreme right point of the whisker on the right. So there are more data on the left. Okay. Suppose that the box plot has a much longer upper whisker. Our case is the opposite. We have a much longer lower whisker. But they're saying suppose that a box has a much longer upper whisker than the lower whisker. What would that tell you about the distribution of values in the dataset? Extended whisker on the right. The length of the whisker on the right is longer than the length of the whisker on the left. That means the dataset is lot of large data point. So in this case, Q2, the median, the line in the center, will be located close to Q1 or the left boundary of the box. Okay. Bottom line, there is skew in the data, more data on the right, heavy weight on the right side of the data set. Okay. Positively skewed, so right skewed means because the whisker on the right is longer than the whisker on the left, we have skew on the right, which is positively skewed. There may be outliers. What is an outlier? Is a number which is far away from the rest of the data. And there is asymmetry. What is asymmetry? Ideally, you would want the line in the center of the box, which is Q2, median, should be at the center of the box. It is not so in this diagram. Okay, so there in this case there is asymmetry in the data because the left half is not equal to the right half. And I already told you the distance from Q2 to the minimum point on the end of left whisker is longer than the distance from Q2 to the maximum point on the right. Okay, so there is more data set on the left. This particular data set is left skewed or negatively skewed because extended tail on the left. Okay, so asymmetry. If the left half is not equal to the right half, then there is asymmetry in the data. Okay, comparing. Okay, here we are comparing two box plots from two sets of data side by side. We immediately look at the spread of the data. Again, remember the boundaries of the box. Left boundary is Q1, right boundary is Q3, vertical line in the center of the box or inside the box is Q2. Left whisker extends to lowest point, right whisker extends to the maximum point. From this comparative box plot, you can look at the relative positions of the quartiles between the two sets of data. So what is an outlier? There is a formal definition for an outlier. An observation that is more than 1.5 parenthesis IQR means 1.5 times 5 times IQR away from the nearest quartile. That is the outlier. Now, what is IQR? The full name for IQR is interquartile range. So we take the interquartile range, which is, if you remember from the last PowerPoint, is Q3 minus Q1, or the width of the box, or the width of the middle 50% of the data, range of the middle 50% of the data, Q3 minus Q1. Multiply that by 1.5. Now Q3 minus Q1 is IQR, interquartile range. Multiply that by 1.5. Then Find out points which are located 1.5 times IQR on the right of Q3 or 1.5 times IQR on the left of Q1, on the left of the box. Okay. So if there are points which are located 1.5 times IQR more than Q3 from the right boundary of the box, those are outliers. Similarly, the points which are located to the left beyond Q1 means the left boundary plus 1.5 IQ, okay, minus 1.5 IQ. That's a outlier. So Q1 minus 1.5 IQ on the left, okay. That's an outlier. Any points located below that Q1 minus 1.5 IQR and any point on the right Q3 plus 1.5 IQR from the Q3 is an outlier. So these are mild outliers. What is the formula for an extreme outlier? You replace 1.5 by 3 times IQR. So any point which is located 3 IQR more than Q3 on the right or below 3 times IQR from Q1 on the left is an outlier. On the left or on the right. Okay. Extreme outlier position. So what is a modified box? Remember I was talking about skeletal box plot. Now I'm talking about modified box plot. The modified box plot will automatically show us the outliers. How do you do a modified outlier box plot with the same data set? So using TI-84, remember we have the data in L1 of the calculator. Again press the second button and Y equal to key on top of it. Then number one, it's already on in the second line, type of the chart. Go to the fourth chart. One, two, three. Three is the histogram. Fourth is the fourth type of chart. This is the modified box plot. What is the advantage of it? It will show you automatically the outliers. If there is any outlier, they will apply this kind of formulas. So put the cursor on the fourth type of chart. Remember the fifth one is the skeletal, which does not show the outlier. The fourth one shows the outlier and hit enter. Okay. And then press the zoom button on the top row and 9. And we make the modified box plot. However, in this case, even the modified box plot, as you see, does not show any outlier. Okay. Let's take a look at this data. Anthropological data source from Lois selected papers in anthropology explores rectangular shapes in Shoshone Indian leather handicrafts. Observation focus on the variable x width to length in a sample of 20 beaded rectangles. So we'll put this data in L1, then make a modified box plot, that is select number 4 and see if there is any outlier. So how do I do that? First I have to clear the memories of the calculator. Again, please note the steps are to clear the memories of the calculator is second button on the top left, then plus button on the bottom right, then select number 4, press number 4, second plus 4. You'll get clear all list on your calculator screen, hit enter, done. Then you press stat button. Stat button is in the second row of key, stat and then 1. Stat and 1 button will give you L1. Okay, enter the data. So we will do row wise. First the top row, first row, and then the second row. So 0.553, 0.57, 0.576, 0.601, 0.606, 0.606, 0.609, 0.611, 0.615, and 0.628. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 data points I have in the first row. Now my cursor is sitting in the 11th row. L1 parenthesis 11 means 11th row from where I will enter the second row of data. Yes, so it is 0.654, 0.662, 0.668, 0.670, 0.672, 0.690, 0.693, 0.749, 0.844, and 0.933. So I have 20 data points. Right now my cursor sits on 21st row of L1. I'm going to make a modified box plot right away because I want to see if there is any outlier on the left or on the right. So I press second button on the top left, second button on the top left, and then Y equal to key just on top of it. Second Y equal to. So second Y equal to. Let me. So second button and Y equal to key on top of it. Second button and Y equal to key on top of it. I got this thing. Then I press number 1, flashing on. Type is the fourth type of chart and hit enter. Then zoom, which is in the top row. Second Y equal to plot number 1 is on. Then type is the fourth type of chart, 1, 2, 3, 4. Then zoom, third key. Zoom 9. And we can see two outliers on the right. Yeah, you see those two squares on the right, extreme right? The calculator will show you the outlier. It does not tell you whether it's an extreme outlier or a mild outlier. It applies the formula 1.5 IQR from the third quartile. So any point located outside Q3 plus 1.5 IQR is an outlier. Here there are two outliers on the right shown by the two separate boxes. These are the last two high numbers. Okay. Now, question is, in this case, the right whisker extends to number 0.749, which is the lowest point just below the two outliers, 0.844, 0.93. So the right cursor extends only up to 0.749. The last 2 points are outliers. Okay. So this is the calculation. They do the upper quartile calculation, Q3 plus 1.5 IQR. The boundary is 0.7935. Any 2 points above those. So 0.7935. So 0.844 and 0.933 are outliers on the right. Okay. There is no outlier on the left because the lowest point is 0.553. And you can also notice that the last data point, 0.933, is actually Q3 plus a third, 2 times IQR. So they did the calculation for 3 times IQR in 0.225, and that becomes the last point in the data set. 0.844 and 0.933 as up outliers, with 0.933 being an extreme outlier. How did you calculate? It is Q3 plus 3 times IQR. It is even greater than that. Q3 plus 3 times IQR is 0.933. But our, sorry, Q3 plus 3 times IQR. What is your Q3? Is the upper quartile, 0.681 plus 0.225. That will put you in 0.906, something like that. But your last point, last data point, which is 0.933, is even beyond 3 IQR, 3 times IQR on the right of uh, Q3. Okay, so it's an extreme outlier. Okay, and they show it everything over here. Okay, so I stop here today. I told you I'm going to give you some tips. The tip is to enter the data in L1. So then second Y equal to, and select plot 1, then select number fourth plot, which is the modified box plot. That will straight away show you the outliers on the right or on the left. But important point to note, in a box plot, the lower boundary, the lower vertical line, the lower boundary of the box is Q1, the right boundary is Q3, The line inside the box is Q2 or median. If there is no outlier, the left whisker extends to the uh, minimum point, and if there is no outlier on the right whisker extends to the maximum value. But if you use the modified box plot, then you easily locate outlier. And the calculator uses the formula for the upper outlier boundary is Q3 plus 1.5 IQR, that is our mild outlier. For extreme outliers is Q3 plus 3 times IQR. You ask what is IQR? It is the interquartile range. Please remember that. It is the width of the box, Q3 minus Q1. Okay. So that's what interquartile range gives us, the range of the middle 50% of the data. That, hence the name is interquartile range. Upper quartile, which is Q3, minus lower quartile, which is Q1. Q3 minus Q1 is interquartile range. Okay. So a modified box plot shows you the outlier. A normal box plot or a skeletal box plot does not show you the outlier. The purpose of doing the box plot is to show the spread in the data, the variability in the data, the characteristics of the data, and if there are any outliers or not at all. So I stop here today. If you like this video, please give me a thumbs up. That really motivates me. And please let me know, where are you watching this video from? Do you like my video? What else you want me to cover in these videos? Okay. If you like this video, share with your friends. Please give me a thumbs up. Please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to click on the bell button, which will notify you, notification button. It will notify you every time I upload a new video. Thanks for watching. Have a nice day. I appreciate it. And please do not forget to check me out tomorrow when I'll be back with another interesting video.